Think about how something as simple as word order could affect, like how well a machine understands it, you know?
Yeah.
So get this, some researchers actually found that just by messing with word order, they boosted machine translation results by 5%. Wild, right?
It's pretty amazing, yeah, how these systems we think of as so complex can be sensitive to things you might not even consider.
Totally. And that's what we're diving into today, actually. It's all about how order matters in machine learning. We've got this research paper, right?
Right.
And it goes way beyond just words. We're talking about how the order of data, any data, affects all sorts of stuff, analyzing sentences, even something called a convex hull computation, basically
Yeah.
like figuring out the shape of stuff with algorithms.
Exactly. And it really challenges how we think about machine learning, especially with these models, sequence-to-sequence models, SECATO for short.
Mm.
They're made for data where order is the thing,
Oh, yeah.
sentences.
Makes sense. Feed it words in order. It spits out, say, a translation in another language, also in order. But what happens when you use that on data where order shouldn't matter? Like a set of things. That's what's wild about this paper.
Right. Think about it, a set of numbers you want to sort. Shouldn't matter how you give those numbers to the model. The sorted output's the same, right? But it turns out it does.
So how do you even do that? Feed a jumbled set into a system that wants a line. How do they reconcile that?
That's the key, isn't it? They made this new model, read process right, just for this. So the read part, it takes each thing, like our numbers, and gets them ready for the model.
Like giving them little name tags before the sorting contest?
Exactly. Then process, that's where a special kind of network comes in, an LSTM. But here's the trick. It handles those name tag numbers without any set order, like shuffling them in a box so the model doesn't get biased.
Sneaky. And then, right, that's where the sorting magic happens.
Right. Another network takes over, uses that jumbled info to actually output the sorted sequence. And what's amazing is, this new way, it crushed the old methods, especially with bigger sets.
Like trying to fit square pegs in round holes if you use the old stuff.
Yeah.
You need a system that sets aren't about order.
And that's what they found. You can't just force it and expect it to work right. But it gets even more interesting when we talk about outputting sets, not just encoding them.
So wait, even when the model's spitting out a set, the order it gives those things back to us, that matters. I thought as long as the final set's right, who cares?
You'd think, right. In theory, shouldn't. But that's the thing this research shows. Real-world training, it's different. Even if multiple orderings work, some just work better for the model to learn.
Huh. Okay, that's wild. So it's not just how we feed the data in, but how it's trained to give it back.
Exactly. And that's what's cool. It led to this idea. Why not let the model figure out the best order itself? Instead of us deciding the output structure, let it learn the most efficient way during training.
Like, we give it ingredients, but instead of a strict recipe, it can experiment to find what works best.
Perfect analogy. And to make that search easier, they use some smart techniques. Pre-training, giving it a head start, and sampling, trying out arrangements strategically, not every single one, like finding shortcuts in a maze.
Slick. But how they actually test that whole let it learn thing? What was the proving ground?
They used a classic problem, natural language processing, called 5-gram language modeling. Imagine trying to predict the next word in a sentence, using the 4 words before it as clues.
Oh, like our phone's predictive text, but way smarter.
Exactly. And what they found, even in that simpler language task, the order you feed those 5 grams to the model, huge impact on how well it did.
So some orders just clicked better, made it easier to get the relationship between words and predict right.
Yep. And the exciting part, when they let the model learn its own best order during training, it consistently found ones that were way better than random or fixed order.
So it's like it unlocked this hidden level just by figuring out how to look at the info the right way.
Exactly. And this isn't just about language. If something as basic as order has this big an effect, makes you wonder what else we're missing, right? What other subtle things are out there?
Makes you think, you know, how many times you're stuck on something, then someone just looks at it differently, and suddenly, boom, obvious answer.
It's like it was there all along.
Exactly. Just got to see it the right way. And that's kind of what's cool about this whole machine learning thing. It shows us those hidden angles, things we'd miss.
But also, it's a reminder for us, right, to not get stuck in our ways.
Totally. Like, we assume something's got to be a certain way, but this order thing proves that even the tiniest change can completely flip the script.
Huge impact from something so small you wouldn't think it, but...
Exactly. And that's why we do this deep dive stuff.
Right. Got to dig into those little details.
Because they lead to the big breakthroughs.
Exactly.
Yeah. So, to everyone listening, next time you're hitting a wall, try this. Think about the order of things. Might just find you have the solution all along, just got to rearrange it a bit.
At the very least, you'll look at things a little differently. And that's never a bad thing.